Hello friends, this is Shanti Dugar from Mumbai. In this video, I am going to explain a different approach to standard costing and variance analysis, and this is part 1 of the total 4 videos I will be presenting on this topic. Before we start, let us understand the meaning of standard costing and variance analysis. According to the Chartered Institute of Management Accountants (CMA) UK, the standard costing is a control technique which compares the standard cost and revenues with actual results to obtain a variance, which are used to facilitate the action through management by exception to stimulate improved performance. So we can see that standard costing purpose is to calculate the variance to improve the performance, and it's a control technique. Now let's understand what is the variance. Variance is simply the deviation of actual cost from the standards or actual revenues from the standards. So this is calculated to control, have a better cost control and revenue optimization. So a variance which increases profit, that means either lower cost or higher revenue than the standards, is called favorable variance. And a variance that reduces profit, that means either higher cost or lower revenue than standards, is called adverse or unfavorable variance. Now let us understand what are the types of cost and revenue variance. So in this chart, I have shown the type of cost variances. That means standard cost minus actual cost, which can be broken into three parts: material cost variance, labor cost variance, and overheads cost variance. Material cost variance can further be split into two parts: material usage variance and material rate variance. And material usage variance can be split into further two parts due to quantity. That means if the production is different than the standards, and material yield variance, which I will be explaining all these concepts in the subsequent slides with some examples. Similarly, material rate variance can also be split into two parts: material price variance (MPV) and materials mix variance. In some of the study books, as per the Institute of Chartered Accountants of India and ICSI, this material mix variance is clubbed with the material usage variance bracket. But this is not correct in my view, and I have put it in the materials rate variance bracket, and I will explain the reasons why I have done so. Similarly, the labor cost variance can be also split into two parts: labor efficiency or usage variance and labor rate variance, and further can be split into further subparts. And overheads can also be split into two parts: variable overhead cost variance VOCV and fixed overhead cost variance FOCV. And these are further can be split into further subparts. Now let us understand how the material cost variances are calculated. First, I will explain in theory and then with some practical examples. So material cost variance, as I said earlier, is the total cost variance is equal to standard material cost minus actual material cost. Or simply mathematically, if we put standard quantity into standard rate minus actual quantity into actual rate. And this can be further split into two parts: material usage variance, as I explained earlier, is the standard quantity minus actual quantity multiplied by the standard rate, or we can say material quantity variance is equal to SQ minus AQ times SR. And the material rate variance is the standard rate minus actual rate times actual quantity, or MRV is equal to SR minus AR times AQ. Now let me explain material usage variance. Material usage variance, as I explained earlier, it's sum of material quantity variance and materials yield variance. The material quantity variance represents how much is the material cost difference attributable to the difference in production quantity compared to the standard production volume. And material yield variance reflects the gain or loss due to overall efficiency. That means the total input to output ratio or yield of the material consumption per unit of production. Now let's see how this is calculated. Materials quantity variance can be calculated simply by standard production quantity minus actual production quantity, that is the difference in the production volumes, multiplied by the standard material consumption ratios. multiplied by the weighted average standard rate of material. So in simple words, SPQ is the standard production quantity minus APQ, that is the actual production quantity, times standard consumption ratio total of all the materials put together, multiplied by the weighted average standard rate of all the materials put together. And how the material yield variance is calculated? This is standard consumption ratio per unit of product. And when I say standard consumption ratio, is the total consumption ratio of all the materials put together minus actual consumption ratio of per unit of product of all the materials put together, times actual production quantity times the standard weighted average rate of all the materials. So simply, if I put in short words, materials yield variance equals to SCR minus ACR times actual production quantity, which is APQ, times weighted average standard rate, that is WASR. And these are the causes which can cause these quantity variance to arise, and these are the causes which can cause yield variance to arise. Now let us understand the second component of cost variance, that is material rate variance. Material rate variance, as I explained earlier, is the sum of material price variance and materials mix variance. Material price variance reflects the difference between standard rate and actual rate of each material for the actual quantity consumed or purchased. So this variance reflects how efficiently or inefficiently the procurement department has purchased each material versus the standard prices. And the material mix variance arises due to difference in actual mix percentage of each material versus the standard mix percentage of material in the overall consumption. Now let me understand the calculations, how the material price variance and material mix variance are calculated. Material price variance is the sum of standard rate of each material minus actual rate of each material times the actual quantity consumed. So in short, we can say MPV equals to sum of SR, that is standard rate of each material, minus AR, that is actual rate of each material, times the actual quantity consumed for that material. And material mix variance is the sum of revised standard quantity of each material. And what is revised standard quantity? I will explain little later in this presentation. Minus the actual quantity of each material times standard rate of each material minus weighted average standard rate of all the materials. So in short, we can say MMV equals to RSQ minus AQ times standard rate for that particular material minus the weighted average standard rate of all the materials. And this I call it as delta standard rate price method, which is different from what we have been taught by ICAI or ICSI or various other institutes. And I will explain why I have changed the formula a little bit, the reason for this. And these are the causes for material price variance to arise. As I said, it arises because of procurement department's efficiency or inefficiency in buying the materials versus the standard price. And material mix variance may arise due to usage of substandard quality or better quality compared to the standards, or changes in materials mix in actual consumption. In this slide, I shall explain material mix variance in more details. First, let us understand why mix variance is important to know and calculate for a better decision making. As I explained in my previous slide, mix variance arises when the actual mix percentage of each material differs from the standard mix percentage of that material in the overall consumption. So mix variance in fact reflects the gain or loss arising due to this difference in actual mix percentage versus the standard mix percentage. And there are two ways to calculate this. The one way which I have devised is the delta standard rate method, which shows it can be calculated by the sum of revised standard quantity of each material minus actual standard quantity of that material multiplied by the standard rate of each material minus the weighted average standard rate of the all the materials. So in short, it is sum of RSQ minus AQ, and this difference is multiplied by the SR minus weighted average standard rate, WASR. So this way you will get the conceptually and directionally correct variance. The another method which is prescribed by various institutes, ICAI, ICSI, or other educational institutes worldwide, is standard rate method. It shows the material mix variance as RSQ minus AQ, which is same here, times SR. So this way also ultimate result will be the same, but directionally and conceptually sometimes the variance will not be correct, because for example, if you consume a cheaper material more in proportion compared to the standard mix, then ideally you should get a gain, whereas this method will show a loss, which is not correct. Whereas this method, delta standard rate method, will show a gain, because if you are consuming a cheaper material more in proportion, there should be gain. So I have explained this with a few examples in this video, and I have created separate video specifically to explain this metal mix variance in greater details. Now let us understand metal mix variance with an example. Here I have taken two raw materials X and Y, and their standard quantity consumption is 12 and 4 respectively, and their standard rate is 8 rupees and 10 rupees per kg respectively. And actual, let's say, suppose X we consume 10 kg and Y we consume 10 kg, and their rates are 11 rupees and 7 rupees respectively in actuals. Now if we put the above information to calculate the total cost as per standard and total cost as per actual, we put it like this. The yellow shaded information are already given. So X 12 kg of material at 8 rupees, so gives a total cost of 96 rupees per for the X, and for Y 4 kg consumption at 10 rupees unit rate, so 40 rupees. So total cost becomes 136 rupees for total 16 kg of materials at weighted average cost of 8 rupees 50 paisa as per standard. Now the same information for actual X value 10 kg of consumption at 11 rupees unit rate, so 110 rupees cost for X, and for material Y 10 kg at 7 rupees unit rate, so becomes 70 rupees total value. So 180 rupees is the total actual cost for 20 kg of material, which gives a weighted average rate of 9 rupees per kg. Now, as per standard rate method, the calculation of mix variance will be like this. X and Y, the RSQ quantity will become 15 and 5, because RSQ is the revised standard quantity. So that means actual quantity in proportion of the standard mix. So if we calculate material X, the RSQ will be 12 divided by 16 is the standard proportion, times 20 is the actual quantity, so 15. And for material Y, 4 divided by 16 is the standard mix, times 20 is the actual quantity, so 5. So 15 5 becomes the revised standard quantity, and actual quantity we know is 10 10 for both the materials. So total becomes 20 both RSQ and AQ, and the standard rate is 8 rupees for X, 10 rupees for Y. So if we multiply the difference of 15 and 10, which is 5 less here, times 8 becomes 40 gain, and for Y we consumed 5 quantity more at the rate of 10 rupees, so there is a loss of 50 rupees. So net net, the sum of mix variance comes to minus 10, or unfavorable variance. Now same thing if we calculate as per my method, delta standard rate method, the difference is multiplied by the difference between SR minus WSR. So since we know X material is cheaper than the weighted average rate, X material rate is 8 rupees, whereas weighted average rate of all the materials is 8 rupees 50 paisa. So if we consume less of X, there should be a loss, and which is reflected here, because we have consumed 5 units less of X at 50 paisa difference, we lose 2 rupees 50 paisa here. And for Y, which is a costlier material compared to the weighted average rate, and we have consumed the costlier material more 5 units. So here again there is a loss of 7 rupees 50 paisa, which is derived by 5 quantity difference times the 1.5 rupees rate difference between the weighted average rate and the standard rate of Y. So we get total unfavorable variance of 10 here. So while both the variance in totality matches, but conceptually the delta standard rate method gives directionally and conceptually correct mix variance compared to standard rate method. Now let us understand with another example. When actual production quantity differs from standard quantity and when the quality of each raw material or source also differs. Here I have taken an example of a sponge iron manufacturing plant which requires Fe as one of the raw material source, and Fe you can get it from three sources: iron ore pellets, iron ore lumps, and iron ore fines. So here in this example, I have given the standard quantity of, let's say, standard production quantity of 1000 metric tons. Actual production is 900 metric tons. So total production ratio per ton of sponge iron is, let's say, 1.5 as per standard and 1.6 as per actual. So total raw material consumed here will be 1500 metric tons, and in actual terms it will be 1440 metric tons. And these are the sources of Fe mix. Let's say iron ore pellets 60%, 30% of iron ore lumps, and 10% of iron ore fines. And their Fe content, let's say, is 66% for pellets, 64% of lumps, and 60% for fines. And their individual rate is, let's say, $150 per ton for pellets, $120 per ton for lumps, and $100 per ton for fines. These are the standards, let's say. Against that actual, suppose we consumed in the ratio of 50, 35, and 15% respectively for pellets, lumps, and fines. And their Fe content also came different: 68% against standard of 60%, for lumps 63% against standard of 64%, and fines 62% against standard of 60%. And rates also differed. Suppose we bought at $153 per ton for pellets, $115 for lumps, and $107 per ton for fines. So here you will find all things are different. Nothing is matching with the standard. Production, consumption ratios, total production, raw material consumption, Fe percentage, rates of the individual raw material, and the mix proportion. So this is a bit complicated, but in the next. So I will present the same information. The yellow shaded information are the given information, and we calculate the total cost of raw material consumed. So here if you see the iron ore pellets, we consumed as per budget or standard. Let's say we consumed $150 rate. Total quantity is 900. How we arrived at 900 is raw material consumption quantity is 1500 tons times 60%. So 900 tons at $150 per ton comes to $135,000. Similarly for lumps, as per standard, we should have consumed 450 metric tons, which is 1500 tons times 30% at the rate of $120. So $54,000 worth iron ore lumps. And similarly fines, we calculate $15,000. So total cost would have been $204,000 for 1500 metric tons of raw material and 1000 tons of production. So total raw material cost per ton of production was $204, which is $204,000 divided by 1000 tons of production. So $204 per ton is the standard raw material cost per metric ton of production. Now same thing we calculate on actual basis. Let's say actual basis, we know the total quantity consumed is 1440 tons, and 50% of that is 720. So 720 tons of iron ore pellet is consumed, and the price is 153 for iron ore pellets. So we consume $24,840 worth of iron ore pellets. Lumps, similarly, we consumed, sorry, 24,840 the difference. We consume total cost of $110,160 for pellets. $57,960 for lumps and $23,112 for fines, and total cost becomes 191,232. And if that we divide by 900 tons, we get a weighted average cost of raw material per ton of production is at $212.48. So which is higher by $8.48. So it is a negative variance, and total positive variance is 12,768, because as per budget the cost would have been $204,000, whereas actual raw material cost is $191,232. So we get a favorable variance of 12,768. Now we have to match this 12,768 in various uh, methods. Now example 2, if we continue, actual production. First, we know the actual production was lower, 900 tons compared to external production. So there will be some savings due to lower production. Then the consumption ratios also differ, because external should have been consumed 1.5, whereas actual consumption ratio is 1.6. Hence, there will be unfavorable variance due to high consumption ratio. The third variance will arise by the weighted average price. As we know, the weighted average price of Fe is $132.80 compared to the weighted average standard rate of $136 per metric ton, despite consuming better quality weighted average metal mix. So a part of the extra price paid is attributable to the higher Fe content, and the balance price variance will be due to reasons other than the Fe content, which we will calculate. And this will be reflected by the procurement department efficiency or inefficiency in negotiations. The next variance will be consumption mix. Consumption mix of iron ore pellets, lumps, and fines are also different. Hence, there will be mix variance. So this, continuing this example, the quantity variance will be calculated due to higher or lower production. The standard production, which we know is 1000 metric tons. The actual production we know is 900. So we produced less 100 tons. At standard material cost per ton of production was $204. So $20,400 is the favorable variance due to lower production quantity. Now variance due to higher or lower consumption ratios will be calculated as such. Standard consumption ratios, which is 1.5. The actual consumption ratio is 1.6 tons per metric ton of production. So we consumed more. So there is a loss of 0.1 tons per metric ton at the rate of total actual production quantity is 900 metric tons. So 0.1 multiplied by 900 times the weighted average standard rate of material is $136. We saw in the table. So total $12,240 is the adverse variance due to higher consumption ratios. Hence, the total quantity variance, if we look at the 20,400 favorable plus 12,240 adverse, the total quantity variance will be $8,160. And the price variance, which is the next one, is the sum of standard price minus actual price times actual quantity. So iron ore pellets, we know standard price was $150. Actual price we purchased was $153. So $3 loss on actual quantity of pellets consumed, 720 tons. So 2160 adverse. Similarly for lumps, we get 2520 favorable, and for fines we get 1512 adverse. So total price variance becomes 1152 adverse, sum of all these three. Now continuing this price variance, we can split into two parts. One part is due to variation in the Fe content, because we know the actual Fe content was not the same as standard Fe content. So if you, how we can calculate that? We know the standard Fe content for pellet was 66%, whereas actual Fe was 68%. So we got actually better quality material. So difference is 2%. The total quantity consumed is 720 tons of pellets. So on 720 tons of pellets at standard price of 227.27 per dollars per FE, the loss comes to 3272.73. So this loss means because we got a better quality product, in financial terms there is a loss, but it will help in the consumption ratio because you got a better Fe content material. Similarly, for iron ore lump, Fe content is lower than the standard by 1%, and the total quantity consumed is 504. So standard price per Fe percentage is $187.5. So there is a gain 945 due to lower content of Fe in the overall material. Similarly, for iron ore fines, the Fe content is higher, so we will have some loss due to better product quality in terms of financially. $720 is the loss coming using the same formula. So we can see here total weighted average Fe content as per standard should have been 64.8%, whereas actual is 65.35. So in the mix, overall mix, we fed a higher Fe content to produce the sponge iron. So the loss is 3047.73 using this formula. Standard Fe percentage minus actual Fe percentage times actual quantity times standard price per Fe percentage. Now the second component of price variance will be due to reasons other than Fe content. That means where the quality has not played the role. So standard price per Fe percentage minus actual price per Fe percentage times actual Fe content purchased, that is the actual quantity consumed in metric ton of each material times the Fe percentage of each material. So let's calculate this. We know standard price per Fe percentage was $227.27 for pellets, $187.5 for lumps, and $166.67 for fines. So weighted average was 209.88. Actual price per Fe percentage is 225 for pellets, 182.54 for lumps, and 172.58 for fines. So weighted average is 203.21. The difference between the two is calculated in this column: 2.27, 4.96, and minus 5.91 for pellets, lumps, and fines respectively. So the weighted average difference is coming to $6.6 per ton. And if we put up here the actual Fe content consumed, 489.60 tons Fe tons we have consumed for pellets, 3175.52 tons we have consumed for lumps Fe in Fe terms, and 133.92 tons we have consumed for fines. So total consumption is 941.04 metric tons in terms of Fe. So we can calculate the variance easily now. 2.27 times 489.6. So this is a favorable variance of 1112.73. Similarly, for lumps, it is 494.96 times 317.52, 1575. And for fines, it's negative 5.91 times 133.92, so minus 792. So totality we get 1895.73 favorable variance. So if we take a total B1 plus B2 is equal to minus 3047.73 coming due to variation in Fe content, and plus 1895.73 coming due to price variance other than the Fe content difference. So net difference is 1152, which was matching with our total price variance calculated in the previous slide. Now let us calculate the metals mix variance. Here we know we consumed raw material, which is pellets, lumps, and fines in different proportion compared to the standard proportion. So mix variance will arise here. And how do we calculate the mix variance? The formula which I explained: revised standard quantity minus actual quantity. This difference is multiplied by the standard rate of individual material minus weighted average standard rate of the entire mix. So that means RSQ minus AQ times SR minus WHR. So here I have put the numbers here. Revised standard quantity for 1440 we convert into standard proportion mix. So we get the pellets 864, 432 of lumps, and 144 tons of fines. So this becomes total 1440. And actual we know we consumed 720 tons of pallets, 504 tons of lumps, and 216 of fines. So 1440 total here in actual also. Standard rate is 150 for pallets, 120 for lumps, 100 for fines, whereas the weighted average mix rate is 136, which we calculated earlier. So here the costlier pellet is costlier material, and costlier material we have consumed less. So there is a favorable variance as per the standard rate method as well as the delta standard rate method. But you see the difference as per delta standard rate method, the difference is only $2,016. That is 136, 150 minus 136 is $14 difference on the difference of the quantity 864 minus 720. So the difference is lower. Whereas the standard rate method shows the gain of $21,600 basis 864 minus 720 times $150, not from the difference of the two prices. Similarly for lumps, this is again a cheaper material compared to the weighted average rate of 136. So here if we have consumed more, so there will be cheaper material we have consumed more, so there will be a favorable variance as per delta standard rate method. Whereas as per standard rate method, since we have consumed more, it does not take into the price difference. It shows loss 8640 adverse. So this is conceptually and directionally not correct. Similarly, for fines, the price is $100, which is far lower than the weighted average price of 136, and we have consumed more quantity. So delta standard rate method will show a gain of 2592, whereas standard rate method will show a loss because we have consumed in absolute terms higher quantity. So standard rate method does not consider the price difference between weighted average standard rate and the standard rate of that particular material. That is the anomaly in the standard rate method, whereas it should have captured that anomaly to calculate the correct mix variance. So if we take the total of these three mix variance 2016 plus 1152 and 2592 as per the delta standard rate method, we get a total 5760 favorable mix variance in the first column. In alternative method also we get the same 5760 by taking total of these three, but this conceptually and directionally not correct. And revised standard quantity, as I have already explained, we calculate iron ore for iron ore pellets, 60% of 1440 is 864. For lumps, 30% of 1440 as per the standard mix was 30%, so it comes to 432. And for fines, 10% of 1440 is 144. This is how the RSQ is calculated. So total material cost variance, if I take, becomes 8160 was the favorable, which was the materials variance due to production quantity difference. 1152 was the variance due to price difference, and 5760 is the variance due to uh, mix variance. So total becomes 12768, which is matching with our overall cost variance, which we saw in the example. So here I have summarized here total cost variance of 12768, which is bifurcated into two parts. One is the quantity variance 8160 favorable, and rate variance is 4608 favorable. Quantity variance is split into two parts. Variance due to production quantity difference was 20,400 favorable, and due to lower or higher consumption ratios, there was a loss of 12,240. So adverse variance. So if we take this total of these two, becomes 8160 favorable. Similarly, the rate variance was split into two parts, price variance and mix variance. Price variance of 1152 was further bifurcated into two parts. Due to Fe content difference was 3047.73 adverse, and due to other than Fe content difference was 1895.73. So if we take the total of these two, becomes price variance of 1152, and mix variance, as I explained, was 5760 favorable. So total of this matches with 12768. Thank you very much. This is how the standard costing and variance analysis I have put in a different perspective than the what we have been traditionally told by premium institutes. So for further explanations and any interactive sessions, you may please contact me at my email ID dugat.shanti68@gmail.com. Thank you very much and bye for now.